The dorsal column tracts are interesting in a way that the name itself tells us where the tracts are lying. They are at the posterior side in the spinal cord. The other interesting fact is that the neuronal fibers from the dorsal root ganglia, which entered the spinal cord, travel through the entire length of the spinal cord till the mid medulla, even before crossing. That means the first order neurons go all the way up to the medulla, where they cross to form the second order neurons. As you can see here, they have crossed to the opposite side. As a rule, I said only the second order neurons will cross. And again, as a rule, they will terminate in the thalamus. Same like the spinothalamic tract, you can see that the second order neurons terminate in the thalamus, specifically in the VPL or the ventroposterolateral nucleus, from where the third set of neurons or the third order neurons come and follow the similar pathway that we had in the spinothalamic tract, means they go to the post-central gyrus or the somatosensory cortex. Again, depending on where they came from, they will either go to the legs or the trunk or the arms. Now I'll start explaining the details with the mini model. This model looks really cute. Now the fibers in the spinal cord, but coming from the upper limb, are more laterally placed compared to the fibers coming from the lower limb, and that is true for both the sides. The upper limb fibers come and terminate in the medulla in the so-called cuneate nucleus. It's labeled here, cuneate nucleus or nucleus cuneatus. The lower limb fibers coming from the spinal cord terminate on a medial nucleus called gracile nucleus or nucleus gracilis. Remember, there is a muscle in the lower limb called gracilis on the medial side in the adductor compartment. So that helps me to remember that the medial nucleus is gracile nucleus or nucleus gracilis. Okay, the first order neurons terminated here. Then what? The second order neurons originate both from the cuneatus and the gracile nucleus. They cross and ascend to the thalamus in the brainstem. A couple of details here. You can see that during decussation or during the crossing procedure, the fibers are not diagonally crossing. Instead, they make an arch, swing like this. For that reason, these fibers are called internal arcuate fibers, and after crossing, they go up like a ribbon. That ribbon is more in the midline, so this is called a medial lemniscus. Lemniscus means ribbon, that is on the medial side. In the lower trunk, which is in the sacral level of the spinal cord, you can see that the first order neurons enter the posterior horn and they ascend on the same side, forming the dorsal column tract. Because it's the lower limb, the tract which is formed is called the fasciculus gracilis or the gracile tract. As we go to the lumbar level and higher up, more and more neurons are added on the lateral side. Okay, they don't cross over, they're just adding along as they pass up. That's why in the thoracic level, when we are adding more neurons, they tend to stand on the lateral side forming this dark purple color tract called the cuneate tract or the fasciculus cuneatus. The same arrangement is followed in the cervical level also. In the medulla, we have the two nuclei. As I said, there is a gracile nucleus and the cuneate nucleus, which will receive the first order neurons. You can see that second order neurons are formed. They cross and ascend on the opposite side. That's what we just now saw. The crossing ones are the arcuate fibers or the internal arcuate fibers. The ones ascending on the opposite side form a compiled tract called medial lemniscus. Now, a small extra detail but very important is the corticospinal tract that we saw in the medulla pretty much occupies the same position throughout the brainstem. It is on the anterior side. The spinothalamic tract, the red color one, occupies the same position throughout the brainstem, whereas the medial lemniscus, which is nothing but the dorsal column tracts, it keeps changing. In the medulla, you can see that it's more antero-posteriorly placed. The head and neck fibers are more here, arm fibers in the middle, and the leg fibers more in the anterior. That's in the medulla. But when you go to the pons, you can see that that tract, which is nothing but the purple tract, has now become horizontal. The head end is here, the body or the trunk here, arms here, and the legs are facing more laterally. Again, when you go to the midbrain, the position of the medial lemniscus is almost opposite. The head end at the bottom, arms and trunks, the leg end is more posterior. So if I isolate that pathway only, you can see that it's actually turning and twisting at different levels. Okay.